Today in 20 Days of Amino Acids, I give you the gift of glycine. Glycine is like that goofball friend of yours who is great for a party, always wins at limbo, but you don't want to invite him to a serious situation. Why do I say this? Well, glycine is a goofball because it's so small. And so if we were to line all the amino acids up by their size, glycine is the smallest. But it makes its presence known. So in proteins, you have the amino acids link up with their side chains sticking out. And so glycine just has this little hydrogen here. And so this makes it so that when the protein folds up, the backbone is going to be less constricted in its folding. And this is going to make it so it's going to disrupt those orderly structures of proteins, things like our beta strands and beta sheets and our alpha helices. The glycine is not going to be good for those because it's going to be so floppy, it can't hold those stable structures. It and proline are kind of oddballs in the secondary structure realm, and so proline has this side chain that wraps up on itself, so it has limited motion, and glycine has too much motion. But the two of them actually can team up to make a collagen triple helix, which is this really cool protein structure that gives your skin its strength. And glycine smallness allows it to work together with those prolines to make this kind of unique triple helix structure. Our bodies can make glycine ourselves, which is great because it's really useful. And we make it from the amino acid serine. Because we can make it ourselves, we say it's non-essential in the dietary sense, meaning we don't need to eat it pre-made in our diet, but it is definitely essential. In fact, even the interconversion of serine to glycine is essential because it is going to be allowing us to do things like transfer one carbon molecule at a time. We can also make purines from glycine parts. And so purines are some of the unique parts of your DNA and your RNA letters. We can make glutathione, which is an antioxidant inside of your cells. And all these great things we can do with the glycine in our body. And there are also things that we can do with it in the lab to keep pH steady, both in our laboratory reactions as well as it's actually used in toiletries and cosmetics to keep pH stable. And NASA has found it in samples taken from comets. So glycine is all over the place, but it's not going to be in those alpha helices, those beta strands, because of its goofball status with that super duper small side chain.